On the evening of the 13th of April 2029, a Friday, people across Europe, Africa and Asia are going to walk outside, look up and watch an asteroid cross the sky with their own eyes. No telescope, no binoculars. A point of light moving fast enough to see it move, sliding across the stars in a few hours. It's a rock 375 meters wide, called Apophis, and it will pass closer to us than our own satellites. This is not a prediction of something that might happen. The date is fixed. The path is known to within a few kilometers, and there's already a spacecraft being built to fly alongside it. So what exactly is coming? How close is it really? And what happens when it gets here? Apophis was discovered in 2004, and it immediately did something no asteroid had done before. Within days of its discovery, astronomers ran its orbit forward and got a number that stopped them cold. A 1 in 37 chance of hitting Earth in 2029. This is the highest impact probability ever assigned to a large asteroid. Not a hypothetical, not a movie. A real object on a real list, with real odds. It got its name from that moment. Apophis is the ancient Egyptian serpent of chaos and darkness, the thing that tried to swallow the sun. And at 375 meters across, if it had hit, it would have not ended humanity, but it would have released energy in the range of 1,000 megatons, enough to flatten a region or to raise a tsunami across an ocean basin. Then, over the following years, astronomers did what astronomers do. They kept watching. Thousands of observations. Radar bounced off its surface. Its orbit refined again and again. And the impact probability fell to 0. Not very unlikely. 0 for 2029. And effectively ruled out for the next 100 years. The serpent misses us, but it misses us by an almost absurdly small margin. Here's the distance, and it deserves a moment. Apophis will pass about 32,000 kilometers above Earth's surface. The moon is roughly 384,000 kilometers away, so this is less than a tenth of the way to the moon. That alone is close. But there's a better comparison, and it's one that makes people sit up. Our geostationary satellites, the one carrying television, weather imagery, communications, orbit at about 35,800 kilometers. Apophis passes beneath them, a 375-meter mountain of rock and metal, moving through the space where our own hardware lives. And then out again. And this is not something that happens regularly. An encounter this close with an object this large is estimated to occur about once every 7,500 years. Not once a century. Once every 75 centuries. Nobody alive has seen this, and nobody alive will see it again. So what does it look like from the ground? For most of human history, an asteroid was something you found on a photographic plate. This one you will find by looking up. As Apophis makes its approach, it will brighten to roughly the visibility of the stars and the Little Dipper. Faint but genuinely naked eye from a dark enough sky. The best view falls across Europe, Africa, and Western Asia. Billions of people will be on the right side of the planet at the right moment. And because it's passing so close, it will not creep across the sky the way planets do over months. It will visibly move, crossing a span of sky in a matter of hours, fast enough that if you look away and look back, it shifted. Think about what that is. Not a picture from a spacecraft, not a simulation on a screen. An object from the asteroid belt's neighborhood, close enough that the naked human eye can follow it, on a specific evening from our own backyard. There's a whole generation of people who will remember exactly where they were standing. Now the part that makes this scientifically extraordinary, rather than just spectacular. When Apophis comes that close, Earth's gravity does not just bend its path, it pulls on the asteroid unevenly, harder on the near side than the far side, and that difference is a tidal force. For a solid block of iron, that would mean very little. But Apophis is very likely not a solid block. Objects like this tend to be rubble piles, loose collections of rock and dust held together weakly, more like a gravel heap than a boulder. So when the tidal force arrives, things should move. Researchers expect the encounter to change how the asteroid spins and to trigger surface activity, landslides, quakes, material shifting and sliding. Fresh rock buried for millions of years may be dragged up into daylight. Apophis may arrive as one object and leave as a different one. And that is why this matters beyond the spectacle. We've spent years learning to deflect asteroids, smashing a spacecraft into one, measuring the result. But to move a dangerous asteroid, you need to know what it's made of and how it holds together. Normally, to test that, we would have to fly out and do something to it. This time, Earth does the experiment for us. Nature brings the asteroid to our doorstep and applies the force itself. And all we have to do is be there to watch. Which brings us to what's happening right now, on the ground. Europe is building a spacecraft specifically to be there. It's called Ramses, the Rapid Apophis mission for space safety. And after years of uncertainty, it's real. Fully committed by Europe's space ministers, with construction contracts signed and a total value of around 150 million euros. It launches in the spring of 2028 on a Japanese rocket and arrives at Apophis in February 2029, 2 months before the flyby. That timing is the entire point. Ramses gets there early, surveys the asteroid in detail, shape, surface, spin, and orientation, then rides alongside it through the encounter and surveys it again afterwards. A before, during, and after portrait of an asteroid being squeezed by a planet. It carries 2 small CubeSats to extend its reach, and one of them, named Don Quixote, is designed to attempt something remarkable, landing on Apophis itself. It's not alone. NASA's osiris-apex spacecraft, the one that brought back a sample from the asteroid Bennu, never came home. It was renamed osiris-apex and redirected to Apophis, and will arrive shortly after the flyby to study what changed. Japan's Destiny Plus is expected to swing past. Chinese scientists have proposed their own pair of small spacecraft. There's genuine international momentum toward a single rock and a single date. One honest note on that. The American half is not fully secure. NASA's most recent budget proposal offered no funding for osiris-apex, though Congress overruled a similar attempt the year before. Europe's mission is funded and being built. America is still, to some degree, a political question. There's one more layer to this, and it's the reason space agencies care so much. Apophis is not dangerous, but something eventually will be. And the hard part of planetary defense is not only the technology, it's coordination. Spotting an object, tracking it, agreeing internationally on what to do, building and launching hardware on a fixed deadline that the universe sets and will not move. Apophis gives us all of that, with the danger removed. A fixed date, a real object, multiple agencies, multiple spacecraft, a launch window that cannot slip. It's a full dress rehearsal for the day the answer actually matters. And we're living through the years when the preparation happens. So mark that date, the 13th of April, 2029, a Friday. On that evening, a rock named after the serpent of chaos will pass beneath our satellites, close enough for your own eyes to follow it across the sky, while a spacecraft flies beside it, filming what our own planet's gravity does to its surface. It will not hit us. It was never going to, in the end. But for a few hours, the sky is going to do something it's not done in 7,500 years, and we're going to be watching from both sides at once. This channel is about exactly these moments, the ones where the universe comes close enough to touch. If you want to be here as we get near that date, subscribe and stick around. Until next time, clear skies.